In this video, we are going to be looking at the rules for circle geometry and how to apply them. But before we do, let's look at some properties of a circle. So here I have a circle. This is the center of the circle. I have a line drawn from the center of the circle to touch the circumference of the circle. This line is known as the radius. In this circle, this is the center of the circle. I have a line drawn from the circumference of the circle, passes through the center, and then touches the circumference again. This line is known as the diameter. Now the diameter separates the circle into two equal parts, and those equal parts are called the semicircle. Now here I have another circle. This is the center of the circle, and this line doesn't pass through the center of the circle like the diameter. Therefore, this line is known as a chord. So that's the difference between the chord and the diameter. The diameter passes through the center of the circle, the chord does not. And this chord will split the circle into what we call the minor segment and the major segment. So this area down here is called the minor segment, and this area on top here will be called the major segment. So here I have another circle, and this time I have two radii. Radii is the plural of radius. And now these radii will split the circle into the minor sector and the major sector. So this area down here will be called the minor sector, and this area on top here will be called the major sector. Now the part of the circumference that's from here to here will be called the minor arc. So the minor arc is a distance, while the minor sector is an area. Likewise, the major arc will be the distance from here all the way around to here. So the major arc is the longer distance, while the minor arc is the shorter distance. So again, the major arc is a length, while the major sector is an area. So if I have a line that cuts the circle at 2 points, as we can see, this line cuts the circle at this point here and cuts the circle at this point here. This line is known as a secant line. And if I have a line that intersects a circle at 1 point, that line is known as the tangent line. So the secant line intersects the circle at 2 points, and the tangent line intersects the circle at 1 point. So here I have my first rule, rule 1, that says that the angle at the center of the circle is twice the angle at the circumference, standing on the same arc or chord. So here I have an example of that rule. We can see that I have an angle x. The vertex of that angle is at the circumference of the circle. And I have this angle 2x, whose vertex is at the center of the circle. Now notice the arms for the angle x, that's here and here, stands on this arc in red. And the arms for the angle 2x, which is here and here, stands on that same arc in red. Therefore, both angles are standing on the same arc. And hence you can use this rule: angle at the center is twice the angle at the circumference. Now if we were to draw a line from this point to this point, that line would be a chord. And we can see that these two angles are standing on the same chord. Here I have another example of that same rule, just a different orientation. The angle 2x, the vertex is at the center. The angle x, the vertex is at the circumference. Now notice the arms of the angle x, which is this line and this line, stands on this arc in red. And the arms of the angle 2x, which is this line and this line, stands on the same arc in red. Hence, the angle at the center is twice the angle at the circumference. So here we have a question where we want to calculate the magnitude of the angle x, and we want to give reasons for our answer. So the angle x, the vertex is at the center of the circle. The angle 25 degrees, the vertex is at the circumference of the circle. Now notice the arms of the angle. The arms of the angle x stands on this chord in red. The arms of the 25-degree angle stands on this chord in red, which will be standing on the same arc here. Therefore, these two angles satisfy this rule where the angle at the center of the circle is twice the angle at the circumference, standing on the same arc or chord. So I'll write x, which is the angle at the center of the circle, is equal to 2 times 25 degrees. And your answer is 50 degrees. So my reason would be This is the symbol for angle. So angle at center is equal to 2 times angle at circumference. So here I have rule number 2, and there isn't much to this rule. The angle in a semicircle is a right angle. So this line here is the diameter because it passes through the center of the circle, touches the circumference of the circle at one end and the circumference of the circle at the other end. So once the arms of the angle stands on the diameter, that angle at the circumference would be a right angle. So here we have another question where we are required to find the magnitude of the angle ABC, and we are required to give reasons for our answer. So the vertex of the angle is at the letter in the middle, which is B. So AB would be one of the arms of the angle and BC would be the other arm. So let's look at that. AB is one arm of the angle and BC is the other arm. The vertex is at B. So we want to know what's the magnitude of this angle here. Now this line passes through the center of the circle, touches the circumference at one end and the circumference at the other end. So this line is called the diameter. Therefore we have a semicircle here and a semicircle here. Therefore the arms of this angle ABC stands on the diameter and the angle at B is at the circumference. Therefore this angle B is equal to 90 degrees. So I'll have the angle ABC is equal to 90 degrees. And my reason would be angle in a semicircle. So here I have my third rule where we have angles in the same segment of a circle are equal. Now notice the arms of this angle X in blue and the arms of the angle X here in green. They both stand on the same arc. So if I draw a line from where the arms meet here to where they meet across here, this line would be a chord. And we know this would be the minor segment and this would be the major segment. Therefore, these two angles are in the same segment. And notice the two angles, they are at the circumference of the circle. So here I have another question where we want to evaluate the angle PQR and we want to give reasons for our answer. So the angle PQR, the vertex of that angle is at Q. So PQ would be one arm and QR would be the other arm. So PQ is one arm of the angle and Q to R is the other arm of the angle and the vertex is at Q. So this is the angle we want to find. Now notice this 17 degrees angle, the arms stand on the same arc as the angle PQR. And if I were to draw a line where the arms meet on this side to where they meet on this side, this line would be a chord. So this would be the minor segment and up here would be the major segment. So these two angles are at the circumference of the circle on the major segment. Therefore these two angles are in the same segment. Therefore these two angles are equal. So here I have that angle PQR. This is PQR. This angle here is equal to angle PSR. So that's P to S to R. That's a 17 degree angle. So it's equal to 17 degrees. So that means angle PQR is equal to 17 degrees. And my reason would be, this is the symbol for angle with the apostrophe S. So this will be angles in the same segment. So here I have my fourth rule where the opposite angles of a cyclic quadrilateral are supplementary. So cyclic quadrilateral means a quadrilateral, which is a four-sided shape, and all four vertices of that quadrilateral touches the circumference of the circle. So that would be a cyclic quadrilateral. Now if for some reason one of the vertices is not touching the circumference of the circle, it will no longer be a cyclic quadrilateral. And the word supplementary means the two angles add up to 180 degrees. So the angle A and B are opposite to each other. So A plus B would add up to 180 degrees. And the angles X and Y are opposite to each other. So X plus Y would be equal to 180 degrees. So here I have A plus B is equal to 180 degrees. So A and B are supplementary because they are opposite angles of a cyclic quadrilateral. And X plus Y is equal to 180 degrees because X and Y are supplementary because they are the opposite angles of a cyclic quadrilateral. So we are given a question to evaluate the angle X, giving reasons for our answer. Now we can clearly see a four-sided shape where the four vertices touch the circumference of a circle. Therefore, this is a cyclic quadrilateral. And the angle X is opposite to this 105 degrees. Therefore, these two angles would be supplementary. So I'll have X plus 105 degrees is equal to 180 degrees. So X is equal to 180 degrees. And we transfer this positive 105 degrees across the right hand side, and it will turn to negative 105 degrees. So we'll have X is equal to 75 degrees. And our reason would be that these two angles are opposite to each other. They are in a cyclic quadrilateral. So these opposite angles are supplementary. And we can write our reason as opposite angles supplementary. So this is my fifth rule, where I have the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So this X out here would be my exterior angle. We have a four-sided shape within the circle. All four vertices touch the circumference of the circle. Therefore, this is a cyclic quadrilateral. So the exterior angle is equal to the interior opposite angle, because the angle here and this angle here will be opposite to each other. So the exterior angle is equal to the interior opposite angle. Now, if we were working a question where we had to use this rule, the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle, and we wanted to write the reason for our answer, we could write the condensed form of this reason as exterior angle is equal to interior opposite angle.